Hi everyone, today we're going to just review the distance formula and the Pythagorean theorem to practice solving some problems. You will want a calculator because you'll be finding some square roots of imperfect squares. So, as you may recall, Pythagorean theorem deals with right triangles. On a right triangle we have our three sides. We'll call one of these leg A and one leg B. It doesn't matter which one is which. You could call this one B and this one A and this one A and this one B. It doesn't matter. I think I said the same thing twice. Anyway, this longest side does matter. The side that is opposite the right angle and is the longest side, that one we will always call C. And its name is the hypotenuse. So make sure you remember that the hypotenuse is one that matters. It is the longest leg and it is directly across from the right angle. Now, the formula for the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the two legs and c is the hypotenuse. So let's practice finding the missing side length. So, as you can see on this example, my right triangle, I gotta get my pen on, you know how I like to forget that. My right angle is right here, so my hypotenuse is that one right across from it. So we'll call this leg A and this leg B. So in this case, we are looking for side C. So remembering A squared plus B squared equals C squared, we can plug in my numbers and solve for C. Well, A, we're saying is 28, 28 squared, plus B squared, B is 45, equals C squared. Well, 28 squared is 784. You probably want to use your calculator for that. 45 squared is 2025. If I add those together, I will get C squared. And when I do add them together, I get 2,809 equals C squared. Well, that gives me C squared. That is not C. So to find C, I just need to take the square root of both sides. And C will equal approximately 53. I don't think maybe it's exactly 53. I'm going to double check that because I think it very well might be. And if you have trouble finding the square root key on your calculator, remember it is exactly 53. It is the second key with the squared key. Okay, let's move on to our next example. I have another right triangle. This one's turned sideways, trying to confuse you a little bit. So where's my right angle? It is right up here, which means this is my hypotenuse, or C. We'll call this A, and we'll be trying to find B. We don't know what B is. Well, A squared, 35 squared, plus B squared, we don't know what that is yet, equals C squared, and C is 60. Well, 35 squared is 1,225 plus B squared equals C squared. Oh, why did I put a cubed here? C squared, which is 3,600. I'm just going to solve this like an equation. I'm going to subtract, because it is an equation. Subtract 1,225 from both sides. And I get B squared equals 2,375. Last step, I'm going to take the square root of each side, and I get b is approximately 48.73. Rounding to the hundredths place. Often in your instructions, it tells you what place to round to. When in doubt, I usually go to the hundredths place. Okay, now we're going to work a little bit backwards. It wants to know, is this a right triangle? Well, I have three numbers. If I think about a right triangle, what I know about a right triangle is that my longest side is my hypotenuse. So if this is a right triangle, this would have to be my hypotenuse. So the question is 39 squared plus 80 squared equal to 88 squared? Well, 39 squared is 1,521. 80 squared is 6,400. And 88 squared is 7,744. Well, when I add these together, it's going to end in a 21. I know that. 7921. 7921 is not the same as 7744. I don't know why I did a similar. Is not equal to 7744, so this is not a right triangle. Let's look at my next example. Looking at my three numbers, this is my largest one. So if it is a right triangle, that would need to be my hypotenuse. Does 13 squared plus 84 squared equal 85 squared? I know 13 squared is 169. That's one most of us have memorized. 84 squared is 7,056. That is not one most of us have memorized. And does that equal 7,225? Well, if I add these up, I actually get 7,225. And that does equal 7,225. So yes, this is a right triangle. Okay, now we want to find the perimeter of this right triangle. Well, I can count and see how long this side is. It is 1, 2, 3, 4 units long. And this side is 1, 2, 3, 4, 5 units long. But I can't count this, so I'm going to need to figure out what that is. And I can do that because it is a right triangle. And there's my hypotenuse. So 4 squared plus 5 squared will equal c squared. 16 plus 25 equals c squared. 41 is equal to c squared. And my last step is to take the square root of each side, and I will get c is approximately going to be less than 7, more than 6, about 6.4. Around that to 6.4. I think my next number is 0. So does that answer my question though? No, the question is what's the perimeter? So now I have to add up all my sides. 4 plus 5 plus 6.4. Well, this is 9, 15.4 units would be my perimeter. This is a 5, it looks more like a 6. We write it a little neater. Now on this was on a coordinate plane, so we also could have used the distance formula. But if I can count my sides, I usually find that to be a little easier. But if you recall the distance formula, this is useful when you're on a coordinate plane. I have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Then I take the square root of that and I will get the distance. Very related to the Pythagorean theorem, because this is the distance between two of the legs, and 2 points that make a leg, and here's the other leg. So let's test it out. It says find the distance between these 2 points. I'm going to call this y, x, not y, x2 and y2. Boy, I'm losing my mind. Calling this x1 and y1. So my distance formula says I take the square root of -5, my x2, minus my x1, which is 6, and I square that. And I add my y2 minus my y1 squared. Well, -5 minus 6 is -11 to the second power. And -2 minus 3 is -5 to the second power. Now I raise both of those to second power. -11 times -11 is a positive 121. And -5 to second power is positive 25. So the distance between these 2 points is going to be the square root of 146, which is approximately, can be a little bit more than 12. 12 point, let's see if I wrote that down, 0.8, approximately. Let's try another one. I want to find the distance between 3, -4, and -5, -1. Again, my distance, oh, there I go again. My distance formula, I take my x2, I'll call this x2, y2, x1, y1. I could switch them around, it doesn't matter. So 3 minus -5 becomes 3 plus 5 squared, plus -4 minus -1 becomes plus 1 and squared. 3 plus 5 is 8 to the second power, plus -4 plus 1 is -3 to the second power. Eight to the second power, 64. -3 to the second power is 9. So the distance between those 2 points is square root of 73, which is going to be a little more than 8, less than 9. 8.54 approximately. Not exact. It's rounded. Last example. It says on a coordinate plane, target is at 8, -2, and Dairy Queen is at -3, 2. And we want to know the distance between those two places. x2, y2, x1, y1. So square root 8 minus -3 becomes 8 plus 3 squared, plus -2 minus 2 squared. Square root of 11 squared plus -2 minus 2 is -4. to the second power. 11 to the second power is 121. Negative 4 to the second power is 16. So the distance between those 2 points is square root of 137, which is approximately 11.7. That's it. You know where to find me if you have any questions. Have a great day.